Bismillahirrahmanirrahim. Today we are going to learn about the correlation coefficient. Correlation coefficient is showing the relationship between two parameters. The two parameters should always be numerical and countable. For example, we can measure the correlation between the age and a specific disease. By increasing the age, either it increases the percentage of that disease or not. For example, by increasing the age, it increases the chances of Alzheimer, Parkinson, diabetes mellitus, cardiovascular, and any other diseases. Majority of diseases are age dependent. We can also measure the relationship between the dose and response. By increasing the dose, either the response of the drug or the effect of the drug is increased or not. We can sort out with the help of correlation coefficient. We can also find out the quantity versus quality. By increasing the quantity of any parameter can affect the quality of that object or not, of the quality of that product or not. We can also correlate any other parameter which must be in 2 in number. For example, we are going to find out the age versus disease. By increasing the age, either it increases the chances of that disease or not. For example, these are age in number, and this is 10 years, 20 years, 30 years, 40 years, 50 years, and up to 90 years. We can contract it up to 80 years. This column shows the number of patients. For example, 10 years of age, the number of patients of Alzheimer's disease were 4 in number. Similarly, at the age of 20, the Alzheimer's disease patient was 8 in number. Similarly, at the age of 30, I'm going to write all these: 20, 26, 84, 224. At the age of 70, this is 488, 746 at the age of 80. So I'm going to correlate these. We will select all these, then we will go to the insert, then the scatter diagram, then the first scatter with only markers. Okay, and we can see over here a graph. This graph represents what? This graph represents the correlation graph. I'm going to further explain it. Now we will go to the layout, then the trend line, then the more trend line option. Over here, it shows the R square on the chart. I'm going to R square actually represent the correlation, the square of correlation, and this equation will show the slope. I'm going to close it. So over here we can get now the formula. I'm going to explain it further, but I'm going to remove the grid lines. Grid lines have been removed, and you can see over here, I'm going to make it a bit. You can see over here that the correlation coefficient over here, the square of correlation is 0.762. If I'm going to calculate it, then is equal to CORREL, correlation, start of the bracket, the first array, then comma, and then the second array, and then close the bracket. You can see over here that 0.8732 was the correlation. This is the value of R. This is the value of R, but the value of R square will be is equal to this raised to the power 2. You can see over here that the R square is 0.762. So This is the correlation. The by increasing the value of correlation, the correlation coefficient can be from 0 to 1. So 0.762, this value shows that there is a correlation, there is a candid correlation between the two parameters, between the age and disease. If we change the value of these diseases or value of these parameters, automatically it will be changed. It will be this value will be changed. For example, I'm going to change the last three values. 224 instead of 224. If I'm going to decrease, if I decrease these value, then this will be decreased, and this decrease in this number show that there is no correlation. Increasing this value is showing that there is a good correlation. For example, if the value of r square of the value of r is 1, it means that there is 100% relationship between the two parameters. If the value of r square is lesser than 0.5, it means that there is a weak correlation between the two parameters. For example, I am going to show you over here. For example, I am going to decrease the value of number of patients to 24. This is only 20, and this is only 18. So now you can see over here, I'm not going to show this. You can see over here that there is no there is no specific slope, there is no specific linear correlation, and the value of r square is completely what? The value of r square is very much decreased, 0.07. You can also get it from this area. The value of r square, the r square value is very much decreased over here. This is very much decreased, 0.071. If we increase these values, then it will be automatically increased. For example, if this is 488, now you can see 0.3. If this is 267, now this is again, this is increased. This is 148. This is 0.77, 0.76. There is a good correlation over here. But if we increase this very much proportionally, there is a good correlation. Then, for example, at the age of 10 there is 20 patient, at the age of 20 there is 40 patient, at the age of 30 there is 60 patient, there is 60 patient, at the age of 40 there is 80 patients, there is 100 patients, there is 120 patients, 140 patients, and 160 patients. Now you can see that the value of r square is 1, the value of r is 1. There is a good correlation between the two parameters. The two parameters are proportionally increasing. The two parameters are very much correlated with each other. So this can't be more than 1. The correlation coefficient cannot be more than 1, but it can be lesser than 1. But if the value of r square or r is lesser than 0.5, it means that the correlation coefficient or the correlation between the two parameters is less. Okay.